Hello everyone, welcome to another video. Today we are going to be converting degrees to radians and vice versa. Now guys, there are basically two ways to measure a circle. Either we can go ahead and do radians, or we could go ahead and use degrees. Radians or degrees. This is of course all in preparation for the unit circle, which will be coming up very shortly. So you have to be able to convert from degrees, okay, to radians very quickly. And then of course, vice versa from radian, which typically involves pi or a decimal, okay, from radians to back to degree measures. So as we move forward through this, you have to be flexible between the two measurements, guys. Now, what you have to remember is that one revolution, which represents a full circle, the distance around a full circle, is equivalent to 2 pi if you're measuring it in radians. And so if you were to have a circle and you wanted to find its circumference, and you had a radius of 1 unit, the circumference formula obviously is 2 pi r, so you would do 2 pi times 1, and that would be equivalent to 2 pi. That is why one revolution, a full circle, is 2 pi radians. So if one revolution is the distance around the entire circle, then this also means that one revolution could also be equivalent to 360 degrees. So guys, essentially, one revolution is the same thing as 2 pi, and it's the same thing as 360 degrees. So can we go ahead and summarize this? Of course we can summarize it. We can summarize it into this. 2 pi radians is equivalent to 360 degrees. Now, additionally, we can simplify this equation, all right, by dividing both sides by 2. So then this would simplify to pi radians is equivalent to 180 degrees. Now, that was just dividing both sides by 2, guys. So that's just some basic math, just reducing the equation there. So guys, if pi radians is equivalent to, I'm trying to get rid of the screen here, 180 degrees, okay? Then this would mean that 1 radian would be equivalent to 180 degrees over pi, okay? 180 over pi degrees. And to get at this, to arrive at this equation right here, all we're simply doing is dividing both sides by pi, guys. So if we can do that, and we know that 1 radian is equal to 180 over pi degrees, likewise, we can do the same thing with the degrees. We can divide both sides by 180, and if we divide both sides by 180, this would result in this equation right here, where 1 degree is equivalent to pi over 180 radians. Now, obviously, we're getting a general formula here, as in if 1 radian is equal to 180 pi degrees, and 1 degree is equivalent to pi over 180 degrees. So we can formulate all of this, summarize all of this into a really nice formula to convert from degree to radians and from radians to degree. So bottom line is this, guys, to convert your degrees to radians, if you're going to convert degrees to radians, you are simply, guys, going to multiply, all right, by pi over 180. So if you're converting from degree to radians, multiply by pi over 180. Now, I'm going to do some specific examples for you guys so you can see what I'm talking about. Notice, guys, the degree measure ended up in the bottom so that when you start simplifying, you can do a cross simplifying, cross reducing, so the degrees can reduce out. Now, let's say we had to convert 40 degrees into radians. We would take that 40 degrees and multiply it by pi over 180. Now, of course, if you want to, you could put the 40 degrees over 1. So you're just multiplying two basic fractions. Eliminate the zeros, and then simplify the 4 and the 18. They're both divisible by 2. 2 goes into 4 2 times. 2 goes into 18 9 times. So what you end up with is 2 pi over 9 radians. Or you could rewrite this as 2/9 pi radians. It doesn't matter which way you write it, but typically, guys, the first way is acceptable, the 2 pi over 9 radians. All right, so we're going to do another one, guys, and here it is. And this one is 200 degrees. We're going to convert it to, again, radians. So we eliminate the zeros. I like eliminating the zeros. And then we're going to simplify the 20 and the 18. 2 goes into 20 10 times. 2 goes into 18 how many times? 9 times. So what are you left with? 10 pi over 9. I mean 10, okay? Over 9. And so, guys, that's just the basics of converting from degree to radians. And all you do is multiply each degree by pi over 180. Very straightforward. So now we're going to do it in reverse. So if we're going to convert from radians to degree measures, so this time around, we're going to have to multiply the radian measure by 180 over pi, guys. And of course, just like with the previous examples, I'm going to do some examples right here for you too. So here is the first example, guys. We are going to convert pi over 5 radians to degree. So again, we're going to take this and multiply it by 180 over pi. Notice the pi's are across from each other, so they could cancel each other out. And then 5 goes into 180 how many times? 36 times. So there you go, guys. There's your 36 degrees, okay? It's that easy, guys. It's not difficult at all, okay? So this is straightforward. We're going to do another example. Now, for this example right here, very similar to the previous one, we are going to go ahead and convert radians to degrees. So on this one right here, okay, where's my pen here? This is not writing. Now, give it a moment, guys. It's going to come up. There we go. So these are some basic measurements that you guys should be aware of. You need to be able to fluidly convert these basic degree measurements over to radian measures, okay? Now, guys, these, you will become so used to them, after a while, you don't even have to work out anything. You can just come up with it automatically, okay? And I want that fluidity to become a part of how you move through the rest of this class. So if you're converting 30 degrees to radians, you multiply the 30 by pi over 180, cancel out the zeros. 3 goes into 18 6 times, so you're left with pi over 6. So you should know that 30 degrees is the same thing as pi over 6 radians, or 1/6 of a pi. Now, of course, make sure to use some of that common sense too. If you were to take 30 divided by 360, that would simplify to pi over 6, obviously, okay? So guys, let's go ahead and keep going. I mean, oh, Shazam, 30 over 180, that would simplify to pi over 6. So now we're going to do the 45 degrees, same thing. 45 goes into 180 4 times, so that leaves you with pi over 4. And so pi over 4 is the same thing as 1/4 pi. Now we're going to use some common sense. 45 degrees out of 180, guys. When you simplify that, that's what it simplifies to, 1/4, okay? Now, the reason why I'm not using the 360 is because, remember, we're going based off the fact that 1 pi is equivalent to 180. So likewise with the 60, if we were to take the 60 divided by 180, when it simplifies out, it would simplify to a third of 180. So 60 degrees would be equivalent to pi over 3, or 1/3. Now guys, that's the fluidity I want from you all, okay? as we move to the unit circle. This is all in preparation for the unit circle, which will be coming up later on this week. So I want you to be able to quickly convert degrees to radian and vice versa, radians to degree measures. Now, here's one of the ones, guys, where you can use good old-fashioned common sense. Let's say you have 90 degrees, okay? 90 degrees. Now, 90 degrees, think about it. In terms of 180, if you take 90 degrees and divide by 180, that's a half. So half of a pi would be equivalent to the 90 degrees. Likewise, if we were to take 90 degrees and divide it by 360, 90 out of 360 would be a quarter. And remember, the circle is also equivalent to 2 pi. So if we were to take 1/4 of 2 pi, guys, that would give you pi over 4. Over 2, I'm sorry. So guys, as you can tell, a lot of this is good old-fashioned common sense, basic math. So you guys should be just fine with it. And if you ever get lost, if you're not sure what's going on, do it the long way. Take that 90, multiply it by pi over 180, and just go ahead and simplify. So you should be able to come up with some of these basic conversions from from radians to degrees, and then from degree to radians, okay? So here are some additional examples, guys, where we are converting radian measures to degree measures. For example, if you have pi over 20, to simplify that, we'd multiply it by 180 over pi. The pi's, of course, would cancel out. Zeros cancel out. 2 goes into 18 how many times? 9 times. So pi over 180 would be 9 degrees. Pi over 20 would be 9 degrees. I'm sorry. There was just a bug here, okay? Now, 2 pi over 5, guys, is another one. 180 over pi. You multiply it, cancel out those pi's, and then you want to figure out how many times 5 goes into 180. That would be 36 times. And 2 times 36 will give you, what? 72 degrees. And guys, just like that, that's it. That's all you have to do for these problems. It's not that difficult. You just got to get used to the process. And so we are going to be going over some of these problems in class together from assignment number 3. So if you're a little lost, it's okay, guys. We'll go over the problems one by one in class. And so make sure to ask plenty of questions. Like if we're converting 80 degrees to radian measures, again, simplify the zeros. 2 goes into 8 4 times, 2 goes into 18 9 times. And so that leaves you with 4 over 9 pi. I feel like I did this one before. So there, okay? Maybe I didn't, okay? But guys, this is the last one, 120 degrees. We're converting it to radians. So you multiply by pi over 180, cancel out the zeros, of course. And then 6 goes into 12 2 times, 6 goes into 18 3 times. And so this simplifies to what? 2 pi over 3, guys. So 120 degrees is approximately 2/3 of pi, which makes sense, guys, because 120 degrees is less than 180, okay? So that's it. Bye. Until next time, guys. Have a good one.